this video, we will describe the basic text-to-image tab inside Automatic1111, which can be used to generate Stable Diffusion pictures, or more precisely, Stable Diffusion model. So what you can see is actually the text-to-image tab, which is the most basic tab inside the Automatic1111. There is loaded SDXL base model, which we will be using. So let's start from the top. So Stable Diffusion checkpoints, which are simply learned weights used to run this deep learning model. So if we click here, we can select model that we put into the model folder where our Automatic1111 is installed, and then we can just change the model and it will be automatically reloaded. But for now, let's keep the SDXL. Through this button, we can just request reloading of the model. Now, if we move into the prompt, so these two text boxes are used to put in so-called positive prompt and negative prompt. So what is the difference in between these two? So positive prompt is steering the reverse diffusion or denoising process to reach the picture that we've described inside this positive prompt. So it's driving the result toward the prompt. So for example, if we put there a man, then the reverse diffusion process or denoising process will go in a way to generate a picture of a man. On the other hand, the negative prompt is allowing us to fine-tune the result, because we can mention here what we do not want to see. So for example, we can put there a word like ugly, or for example, if we do not want to have a man with blue eyes, we can put into negative prompt blue eyes. So it will be a man, and negative prompt blue eyes. And negative prompt is actually steering the denoising process away of something. So in our case, it will be steering away from blue eyes. Then we have here drop down for sampling method. Sampling method is simply some algorithm which is solving the diffusion equations. More precisely, it's controlling the denoising process. So there is a lot of different samplers, very simply said. These samplers are giving you some balance in between quality of generated picture and the speed. The two most used samplers are Euler, or then I use DPM++2M Keras. So these are usually two most used models, which are giving you the best balance in between speed and quality. The sampling steps is how many times the denoiser will remove some noise out of the picture, so how many times this algorithm repeats itself. Usually good balance is in between 20 to 30. If you go over 30, then usually it's not really beneficial. And if you just hover mouse about it, there is a mentioned some brief description. So of course, if you give it, for example, 40 sampling steps, it will take longer. So it's about just experimenting, but as I mentioned, 20 to 30 is usually good balance. Then, because it's known that Stable Diffusion version 1.1.4 and 1.5 are not really good at generating faces, inside Automatic1111 is built in way how to restore faces. It's another deep learning AI. So if you hit restore faces, when the picture is generated, is passed into this different AI deep learning model, which is responsible for finding and restoring faces. Then tiling is used when you want to generate some style that can be tiled, which means, for example, you want to, put a present into some paper and you want to have some illustration that can be tiled. So you can use this checkbox. And high-res fix is a special type of upsampling. The difference against the standard upsamplers or upscalers is that this upscaling happens inside so-called latent space. So what is important to realize, if you use this high-res fix when the picture is generated, it will upscale it from 520 by 520 to 1024 by 1024. But the problem is, because this is happening inside a latent space and then through variomatic autoencoder is returned back into the image space, it can change slightly your picture. The benefit is that it may prevent generation of artifacts, but keep in mind that it may a little change your picture. Usually how the upscaling is done, you just move into extras and there are upscalers which can be used. Then we have here width and height, which is just setting width and height of the picture. Keep in mind that version 1 models are trained using 112 by 112. So if you, for example, change it into 1024 by 1024, the model may generate something unexpected, like double head or some artifact. Usually it's safe, for example, if you want to generate a portrait, to change one either width or height, and then it works more or less okay. But at least one parameter has to stay the same as the one that the model was trained against. Then we have these two, batch count and batch size. So usually when you enter some prompt, you want to test the prompt. So you change the batch size, for example, into 4, which means that when the generation pipeline is run, it will generate during this single run 4 images. And you can just select from these 4 images. It's a very good thing to do because it gives you idea what the prompt can generate. Now, when you are increasing the batch size, you may run into a problem with video memory. So in such case, you can just decrease the batch size and then increase the batch count, and batch count means how many times the full pipeline is run. Batch size is usually faster. If you do not have enough video memory, then you have to decrease the batch size and you can increase the batch count. Now we have a classifier-free guidance scale, and this is simply influencing how much the prompt would be followed and how much the model will be creative. Usually around 7 is a very good balance in between creativity and following the prompt. If you give it 30, it will follow the prompt as much as it can. If you give it 1, it will be super creative, so it will be more or less ignoring the prompt. Again, you can just hover above it and you will get some caption. Then seed is used to generate some randomness inside the latent space, so to generate some random noise, which is then denoised to provide you with a picture. Here you can set seed to -1, which means generate some random number. Or here, if you generate some picture, you can reuse the same seed that was used to generate a picture. And this can be used, for example, to fine-tune the prompt. Because you may generate a picture, you realize that you want to add a ring into the picture or some element into the picture, but you like the picture, so you just copy the seed from the picture and then you just little change the prompt and regenerate. Then Automatic1111 is also offering some scripts. We won't be covering them inside this video, but in general, for example, X, Y, Z plot means that you can automatically change some parameters, like for example, you can change by some steps CFG scale, and it will continue generating pictures and it will create a graph for you. So again, it's very good to test what the prompt can do when you start playing with the parameters here. If you hit extra, it allows you to slightly deviate from the seed, and you can here put, for example, if seed is 1 and you put variation speed 3, and then you can select the variation strength. So 0 means the seed would be used. If you give it the maximum strength, the variation seed would be used, otherwise something in between. And if you use resize seed from width or height, it's helping you to generate kind of similar pictures, but a little different. Because in case of Stable Diffusion models, when you change width or height, then these models tends to generate a lot different picture. So this is a way how to control this and do much, let's say, smaller changes. Then if we go here, we have a generate button, which simply triggers the generation. Here we can read generation parameters and send them into user interface, because the parameters are stored, so you can reload these parameters from the picture that you just generated. Using this icon, you can delete the prompt. Here, extra networks, we won't be covering them inside this video, but I'll just mention that these extra networks are usually used to fine-tune the model. So for example, steer the model into generating some precise style, because the model can generate it, but it may be really difficult to play with prompt to generate it. And so these extra models were created. They are usually either like some small training set which is connected to the model, or they are changing how the text is translated and then sent into the denoiser. And by these little changes, they can control the style or drive the model to generate some specific style with just a simple prompt. Then we have apply style and save style. So if you, for example, create some common or generic negative prompt and you just want to reapply this prompt, you can save this into styles. And then if you select the styles, you can just apply the style and it will automatically put you negative prompt. And then you can just fill in your prompt and start using it. Now, before we try to generate our first picture, let's check 2 pages from where you can download the most models. So probably the most known is Hugging Face. There are many AI models or deep learning models. So here, for example, we opened Stable Diffusion version 1.5. So what I want to mention here, if you want to only use the model, then you will be downloading EMA only safe tensor, or CKPT, which stands for checkpoints. These are just learned weight of the deep learning model. Now, what is the difference in between these four values here? So we can see that every single time we have something which ends with CKPT or safe tensors, these two models are quite huge. These two, which also has EMA only, are much smaller. So what is the difference? These EMA only are meant to be only used to generate pictures, but they can't be used to train them or extra train them. If you want to extra train them, you will be downloading the bigger model. And the difference in between CKPT and safe tensors, in case of PyTorch, where the checkpoints or the values for the weights of the deep learning model, so this format is not safe because it can run some code on your computer. So if you download these checkpoint files, make sure that you are downloading them from safe places. It was improved into the format which is called safe tensors, and safe tensors preventing running or executing some malicious code inside your computer through Python. So that's the difference. And then you may also hear connected with the models that they are either FP16 or FP32. FP16 stands for 16 bits floating point. It's just the way how computers store the decimal numbers. And for models that generate pictures, or in general AI models, is usually sufficient to take the FP16. They are also half as big compared to FP32. And the reason is that usually the FP32 inside these extra 16 bits stores only noise, which is not really important. So it's not really helping the model, but it's just storing noise, and it's making calculation much more difficult, time consuming, and it's also bigger. So usually it's sufficient to just download FP16 models. And then another site from where you can download the models is Civit AI. So I'll put all these links into the description of this video. But now let's conclude our video by trying to generate something. So let's say that we want to generate a statue of David centered. We are using the latest SDXL model. We will use Euler, and SDXL model is trained to generate 1024 by 1024. Let's do a batch size of 2 and let's hit generate and let's see what will happen. And then we will describe the rest of the icons here, and that will be it. And then in the next video we will continue describing the other steps inside automation or Automatic1111 and how they can be used. Okay, so we see as the sampling or denoising process continues that we are getting some pictures. We should get 2 of them. Okay, it's nearly finished. So here down we can see the version of Automatic1111, version of Python, version of PyTorch. If we use Xformers, which is a plugin that can help speed up things on NVIDIA graphic cards. And then we see what is the revision, because inside GitHub we are downloading, and the Automatic1111 can also update itself. So it's here. So we can see that it generated 2 pictures of David. Here is always like a overview and you can just select them. Then here we can open folder with the generated pictures. We can save the picture. We can zip all the pictures. We can send the picture into image to image, which is next step inside Automatic1111. We can send it to in paint, which means we would be like masking a part of the picture and then changing it, which is again inside image to image tab. Or we can send it to extras, which are usually used to either restore faces or, for example, upscale the image. Here we can see nice description, what we used, what is the model, what was a random number generator, what was the seed, and so on. And also here we see how much time it took to generate these 2 pictures. So we are running on my PC on RTX 3060 Titanium with just 8 gigs of memory. So I mean, it's pretty amazing that it generated picture 1024 by 1024, 2 of them in just 1 minute and 10 seconds. Because this graphic card is not really expensive, and even on this it can run this fast. What is probably good to check is here how much memory it's using, I mean video memory. Then we have how much reserve total memory is available for PyTorch. And then here is like a maximum memory, video memory of our graphic card. So it is important to realize here there are some special parameters you can pass into Automatic1111. One of these parameters is called met VRAM or Xformers. So if you have just 8 gigs of memory and you have NVIDIA graphic card, you definitely want to pass Xformers parameter and then met video RAM. And the reason is that then the model is used in a way that it's not loading everything into video memory. So the generation of picture is much faster. So if you have just 8 gigs, definitely pass met VRAM, which is going significantly increase the speed of the images generated. Otherwise, it will try to put all, let's say, 10 gigs into video memory, which is impossible. And then, of course, it will have to swap them, or it will try to use RAM memory, and the generation will be much slower. Just to give you some idea, without the met VRAM, it took me like 4 or 5 minutes, but when I pass this parameter, it's now 1 minute. But in this case, it's 1 minute for 2 pictures. It took me 5 minutes for just 1 picture. So in reality, the 1 picture here is generated in something like 30, maybe 35 seconds. And that's it. This is how to generate the picture. And let's continue in next video with image to image and other magic.